you'll be given a plan and a section. In this plan that you have today, it has 6 columns. There's this column measuring 1500 by 1500 by 400, the size of the footing of the column, and this column is equal to this column, this one, and this one. So there are 4 columns of the same size. Then we have this other column which measures 2000 by 2000 by 400. The column is this one, and it is the same as this column. So these 2 columns are of the same size. The footing measures 2000 by 2000 by a thickness of 400. These other ones, as we have said, they are 1500 by 1500 by 400. The columns are joined by ground beams. You see, in our drawing today, it has footings of columns and ground beams. And we know that we are taking off the foundation of the columns and the ground beams. So the footings of the columns, of course, they have columns, and then they are interconnected by these ground beams that you can see. All right, so the size of these beams is 200 by 300. The measurement of these footings is center to center 3000, center to center 3000. For the wing, the wing is 4000 millimeters. All right, so that one is the plan. So we have taken section Y. So we are viewing the columns this way. You see the arrow points this way. So we are viewing the columns this way. So in the section, we shall have this one. So the footing that measures 1500 by 1500 by 400. We can see the concrete thickness is 400. Then below the concrete, we have a hard core of 50 millimeters hard core. The section of this column is the column measures 200 by 200. The reinforcement is R6. Then the reinforcement at the corners, that is studding, is for Y12. All right. Then at the footing, we have reinforcement, which is U. We are told there are 5 Y16 both ways. So there are 5 Y16 this way, going this way, and also if the column is rectangular, we have Y16 going this way, and also this way. All right. So when you are told 5 Y16 both ways, there are these Y16 going this way and the ones going this way. All right. Then from the footing of the column, we have these reinforcements that are standing. This part of the column is called the stump. Then this part which has the white concrete is called the footing. The footing is this concrete below here, which thickness is 400. The stump is this column below the ground up to where the ground beam begins. Then the ground beam begins from here to here. And we can see this level is above the existing ground level. Then the reinforcements, when they come above the ground, they should have some extensions which are ready for overlap. You see, the column has to continue upwards. Here it's in the ground. So we shall give an allowance to the reinforcement bars for the sake of lapping with the reinforcements that are above the ground. When we come to this footing of 2000 by 2000 by 400, we can see it's just like the other one. It has a base of 50 millimeters hardcore. The thickness of the concrete here, the footing, is 400. Then the section BB, we can see that the size of this stump or the column that is going upwards is 250 millimeters by 250 millimeters. The type of reinforcement in the stirrups are these reinforcements that are going round and round and round with a spacing. They are 6. Okay, the reinforcements at the corners which are going upward, they are standing, they are 4 Y16. All right. So the reinforcement at the footing, it is 7 Y16 and it's both ways. So this way it's 7 Y16 and this way it's 7 Y16. This footing of 1500 by 1500 by 400 is the same as this other column. All right. So we shall begin the takeoff of the columns together, the columns in the foundation together with the stirrups. The takeoff list, we shall do excavation work, which will involve the removal of 150 millimeters topsoil for footing only. Then we shall do concrete. We shall measure all concrete work for the stump and the footing. We have said the stump is that column below the ground before you get to the ground level. The footing is that wind part of concrete that is under the column. We shall take off the formwork. We need to measure that. Then we shall measure the reinforcement steel bars. Key things to remember when you're taking off such a diagram is that the reinforcement, we shall have some assumption that we use basic assumptions in reinforcement. One is that the lapping is 40D, meaning if the diameter of the bars is Y12, the diameter of that bar is 12 millimeters. So if we want to calculate the length of the lapping, we shall take 40 times the diameter, which is 12. So 12 divided by 1,000 to make it in meters. We shall get 40 times 0.012 for steel bar from footing to column. The lapping from the footing to column, the column above the ground, that overlap that needs to be left, it's 40D. Then we have length of bending for reinforcement shall be 5.5D. What do I mean by this? The bending is this. In reinforcements, we always have, they look like this. It's a straight bar, then it has bends at the corners, at the ends. This bend, if you want to calculate the length of this bend, you will take 5.5 times D. So if it is Y12, so it's like D12, you'll take 5.5 times diameter, which is 12. Alright. The length of the hook for a link shall be 24D. The link, it's the stirrup. You see the stirrup is usually like this. It's a straight bar, then it has ends at the corners, like this. Then we have reinforcements at the corners. 5.5 times. Yes. So the length of the hooks, these hooks at the corners, to calculate the length shall be 24. These are basic formulas that we shall use. Then the cover for the concrete. At the footing, the concrete cover shall be 30 millimeters, and for the other members, like the ground beam, it shall be 25 millimeters. So these are some of the things you have to note when we are taking off. Then we shall now begin the taking off. In the taking off, we have said that we will begin with excavation works. When we are doing excavation works, we need to measure. We need to measure the size of the column footing so that we can be able to know what volume of soil we need to excavate. Alright, so we shall begin with the excavation of the topsoil. The topsoil is 150 millimeters thick from the existing level. We shall excavate the topsoil at the footings. You see, these are the footings of the columns that we have. We have these footings. So when we are excavating, we need to come and excavate this area, everywhere where we have the column footing. We excavate the topsoil, then we excavate for the footing. So what is the volume we shall excavate in this column? It shall be 1.5 meters by 1.5 meters, the area. For this one shall be 2 meters by 2 meters, 1.5 by 1.5. So in simple, how many 1.5 by 1.5? 1, 2, 3, 4. So you will find out that we have 4 columns which measures 1.5 by 1.5. We shall go now to 2. For 2, we shall have 2 by 2. There are 2 columns. So it shall be 2 columns, measures 2 by 2. Alright, so when we come to calculating the total area that we shall excavate, a volume of soil of 150 millimeters thick, it shall be 2 times 2 times 2, then multiplied by 150, the thickness of the soil. Alright, so 2 by 2 by 150, which is the thickness of the soil, to get the volume of the soil, shall get 1.2. Then for the other 4 columns, which measures 1.5 by 1.5, to get the volume of the soil shall be 4 multiplied by 1.5 by 1.5 by 0.5, so that you can get 1.35. So the total volume of soil that we shall excavate shall be 2.55 meters cubed. In books that gives you guidelines, for example, if you're using the SMM, you know, taking off will be determined by the type of guidelines that you use. For example, in Kenya, we use the SMM. If in case we are using the SMM instructs us to calculate, to excavate the topsoil in terms of area. So we shall not put 1.5 here, we'll just take the areas alone. Then we shall write excavation of 150 millimeters topsoil from existing level. Then we shall multiply by 0.15 to get the volume here in the description column. But this one is for the general guidelines that you can use. This is the method. Then you need to go and check in your guide if it's the SMM, if it's the NRM2, if it's the ARM4. So you can be able to use your guidelines in taking off. So this one is the general taking off. By the way, if you haven't subscribed to our channel, kindly subscribe, and if you like this content, remember to give this video a thumbs up. Let's continue. After excavating the topsoil, we shall go to excavating the trench depth. You see, at the footings we have excavated for the topsoil. At all footings we have excavated the topsoil. Now we need to go down and deeper. So we need to dig those holes for the columns. So you can see from the section, the footing, which is 1500 by 1500 by 400 from the ground level. This depth is not for the topsoil alone. We can see it is going from the ground level up to the base of the column. It is 1850. Then we have 50 millimeters for the hardcore. So the total depth shall be 1850 plus 50. All right. So we need now to excavate the remaining part. We have already excavated 150 millimeters topsoil, and our total depth is it's 1850 to get down here, together with plus 950 here down. So the total depth that we are excavating is 1900. We have already excavated 150. So what depth do we need to dig further? And that is when we come to excavating here. So it shall be 1850. We deduct 150 for the topsoil. We remain with 1.7. Then we add more excavation for the hardcore, which is 50 millimeters. We get 1.75. So we need to excavate a total volume of the length, the width of the column base, then a depth of 1.75. According to guidelines, this one you excavate according to in ranges. For example, in the SMM we are told to excavate in ranges of 1.5 meters. So you will excavate the first 1.5 meters separately, then you will excavate the remainder separately if it does not exceed 3 meters. The width of the column base, then a depth of. All right. So for the volume of soil that you excavate using the first 1.5 meters, you will take the size of the footing, which is 2 meters by 2 meters. Then the depth is 1.5 meters, because we are excavating in ranges of 1.5. If the total depth is 1.75, the first 1.5 will be separate, so it shall be 1.75 deduct 1.5. It shall be the first range shall be 1.5. The second one shall be the balance, which is 0.25. So when you're excavating the volume of the soil for the columns, it shall be the size of the column 2 meters by 2 meters. Then the depth is 1.5. How many columns measures 2 by 2? 2. 4 columns measures 1.5 by 1.5. Then the depth of excavation is 1.5. So the total volume of soil we shall excavate using the first range, which is 1.5, it shall be this 12 and this one 13.5. So this total volume, which is 25.50, it is excavation of trench depth not exceeding 1.5 meters, any range that is less than 1.5. Then we go to the one exceeding 1.5 meters but not exceeding 3 meters. So the volume of the soil shall be the length of the footing is 2 meters by 2 meters, then the extra depth, which is 0.25 for 2 columns. For the 4 columns shall be 1.5 by 1.5 by the remaining depth, which is 0.25. So the volume shall be 2.25 and the first volume is 2. So the total volume of soil in the next range of 1.5 meters, it shall be 4.25 meters. So what is the total volume of soil that we have excavated? The total volume of excavation shall be these 2.55, 25.50 and 4.25 meters cubed for the excavation. All right. So the volume and the first volume what is the total volume we shall move on to the next part, which is the concrete work. The concrete work, remember, we have our footings. Our footings, we can see here it's 1500 by 1500 by 400. This one is 2000 by 2000 by 400. So if we are taking off for the 2000 by 2000 by 400, what is the volume of this concrete at the footings? So at the footings, we have the length, which is 2000 by 2000 by the thickness is 400. How many columns measures 2000 by 2000? 2 columns. So when it comes to booking it, it shall be 2 columns measuring 2 meters by 2 meters by 40 millimeters wide, 40 millimeters thick. So it shall be 3.20. For the other 4 columns shall be 4 columns which measures 1.5 by 1.5 and the thickness of the concrete is 0.40. So it shall be 3.60. So the total volume of concrete in the footings shall be 6.80 meter cubed. So that is concrete grade. You just you do your assumptions if you're not told in the drawings. Like concrete grade 1 is to 3 is to 6, 20 millimeters aggregate for footings. Then we go to the stumps. Remember, I have already explained to you that this part of the column is called the footing. This below here, which concrete, which is wide. The stump is from this part to this part up to the ground beam. You see? So we are taking off now the stump. The concrete in the stump, what is the volume of that concrete? We are told the length of the stump is 200 by 200. Alright? So we just need to calculate the depth. For the 2000 by 2000 footing, it is 250 by 250. So we just need to calculate the concrete at the stump. So what is the depth from here up to here? That one we shall find out. So if from here the ground level up to below the column footing is 1850, then we shall deduct this the ground beam from here up to here, which is 250 from here to here. Then we shall deduct the footing, which is 400. So I come again from the ground level to here, it's 1850. Then the thickness of the ground beam is 250. How do we get that 250? The thickness of this ground beam is 300. Then you deduct 200, which you deduct 50, which is from the top of the ground beam to the ground level. All right. So 300 divided minus 50 is 250. So 1850 minus 250. Then you deduct 400. All right. So as you can see, it shall be 1.85, 1850, deduct 250, then you deduct 0.4. So the height of the stump is 1.2 meters. So what is the volume of concrete in the stump? So in the footing that is 1500 by 1500, the stump size will be 0.2, 200 by 200 by 1.2 meters. 4 stumps. For the one measuring 250 by 250, there are 2 stumps for the 2 footings. So 2 by 0.25 by 0.25 width by a depth of 1.2. So the volume of concrete in the stump is 0.15. So the total volume of concrete in the stumps shall be 0.19 and 0.15. The total is 0.34 meters cubed. Alright, so we shall now go to the formwork. The formwork in the footings and together with the stump. So the formwork in the footing, we can see the footing is 1500 by 1500. We shall start with the columns at the sides of the footings. If the footing measures 1500 length, 1500 width, then the depth is 400, and we want formwork for the sides. This one we will calculate in terms of area. So for this side of the footing, it shall be 1.5 meters by 0.4 meters. Alright, so how many sides does the column have? Remember, it's a square. So this side is 1.5 by 0.4, 1.5 by 0.4, 1.5.04, then 1.5 times 0.4. So there are 4 sides of the column footing measuring so there are 4 sides of the column footing measuring 1.5 by 0.4. And how many columns measures that? 4 columns. So 4 columns with 4 sides measuring 1.5 by 0.4. So the total area for the footings formwork for the sides of the footing is 9.60. So the other one is there are 2 columns with 4 sides measuring 2 meters by 0.4. So the volume, the area of formwork we need for the footings, because we only support concrete at the sides of the footing, because the other one is laying on the ground. So the total area of the formwork is 6.40. So the total shall be 16 meters squared. Alright, so we shall go to formwork to the sides of the stump. The stump, as I had already showed you, is this part. We need to support it, the formwork, on all sides. We can see the cross section of the stump here. We need to support the formwork here, 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 and here. So what is the area of one side? Then, because it's a square, it's multiplied by 4 sides. So as you can see, this stump measures 200. Alright, so it shall be 0.2 times the height of this stump, which we had already calculated, which is 1.2. Remember, when you calculated the height of the stump from here to here, it's 1.2. So it shall be 0.2 times the height of 1.2. So that is the area of formwork on one side. Then it's a square. A square has 4 sides. So 4 sides, we multiply by 0.2 by 1.2. Then we multiply by the number of columns, which is 4. So when you're booking it, it shall be, we have 4 columns, 4 sides. The height is 1.2. Then the length is 0.2. We get 3.84. Then for the other stump, we have 2 columns, so 2 stumps. Then we have 4 sides of that column, and one side measures 0.25 and the height is 1.20. So the total area of formwork at the sides of the stump is 2.40. So the total area for the sides of the stump is 6.24 meters squared. Alright, so now we shall continue to taking off the reinforcements at the footings of the column. Alright, so you can see at the footing we have reinforcements. We are told we have this one, which is 5y16, and it's both ways. So this one that you can see, and also these ones that you can see the ends, it is 5y16. So it's 1, 2, 3, 4, 5. Then on the other side we have 5 reinforcements. So how do we take off the reinforcement? For the reinforcement, we shall begin with either of the footings, and for this case we shall begin with this footing measuring 2 meters by 2 meters by 400. So we need to know how many reinforcements we will use and the length of each reinforcement. So to get the length of this reinforcement going this way, and this footing is 2 meters, what is the length of this reinforcement bar? It shall be 2 meters. We deduct the cover. You see, between this reinforcement here and the end of the concrete here, we have this space. That space is called the cover. The reinforcement bars do not go to the end, because after concrete is done, the reinforcement bars should be hidden inside the concrete. So the space between that reinforcement bar and the end of the concrete is called the concrete cover. So when we are looking for the length of this reinforcement bar, we have to take the total length of the column, then we deduct the cover this side and cover this side. The covers, we had already said that we will use a cover of 30 millimeters. So if it has a cover of 30 millimeters here and 30 millimeters here, and this base and this footing is 2000, so the remaining length that should have the bar is 2000. We deduct 30 times 2, which is 60. Then we have this bend. You can see this reinforcement bar has a bend here, then it has a bend here. We have to add the length of that bar. So the formula that we shall use, it shall be, we take the 5.5 times diameter. Every bend here measures 5.5 times diameter. In other cases, you will find us using 400. We deduct the cover up and we deduct the cover down. So in this example, we shall use 5.5D. But we shall also do another example that shows, if you're not using 5.5D, how you deduct the cover on top and then the bottom. So you should keep tuned so that you can find that video. So in this case, the bend is 5.5D. So if the reinforcement is like this one, Y16, if it's Y16, the size of the bend shall be 16 times 5.5. 16 millimeters times 5.5. So it shall be 5.5 times 16 over 1000. All right, so that you can get the length of that bend. All right, so in booking, in the description column, you shall write the length of the footing is 2 meters. Then we shall deduct the cover on both sides. It shall be 0.06. So you shall remain with 1.94. Then you add the beds, which is two bends. Each bend is 5.5D. So it shall be 2 bends times 5.5 times the diameter, and it shall give you 0.76. So the total length of each steel bar shall be 2.12. All right. Then when we are booking it here, it shall be MR of Y16 diameter steel bar. So we have 2 footings measuring 2000 by 2000. Then it is both ways, on the length side of the column and on the width side. Then we have 7 numbers. 7 numbers. Where did we get 7 numbers? It's because we are already told here it's 7y16. So there are 7 in number. Each way it's 7. So 7 numbers. Let me come again. 2 footings both ways, 7 number in each way, then the length of the bar, which is 2.12. We shall get 59.36 MR of Y16 diameter steel bar. Then we shall go to the reinforcement for the footing measuring 1.5 by 1.5 by 400. What is the total length of bars that we shall buy? So the length of one bar the total length of the footing is 1.5. We deduct the covers because the reinforcement should not go up to the end. The size of the cover on either side is 30 millimeters. So after you deduct the covers, which is 60 millimeters, then you add the size of the bend. In this case, we are using the size of the bend as 5.5 D. So there are two bends, 5.5 D. So 2 times 5.5 times diameter is 16 over 1,000. So it shall be 1.44. We add 0.176. We get 1.16. Alright. So when we are booking it, it shall be, we have 4 footings both ways. Each way is 5 reinforcements, and one reinforcement measures 1.62. So the total length of reinforcement shall be 64.80. The RMR of Y16, diameter steel bars. This 5, we have already said that we get it from the section. You can see it's 5 Y16 both ways. Alright, so now we shall go to reinforcement at the stump. You can see that the concrete, when we are measuring concrete in the footing, we take this one. But when you are measuring concrete in the stump, we take from here to here is the height. But now we are talking about reinforcements. Despite the fact that concrete is here at the stump, as the footing, and here at the stump, when you are doing reinforcement, the reinforcement at the stump will come into the footing. And this height shall be measured in the stump, because this reinforcement coming into the footing from the stump is for the stump. So we are going to calculate the length of the bars in the stump. So we are told that from here to bottom here it's 1850. If we want to get the length of this reinforcement at the stump, we shall first deduct the length of this ground beam, which is here, which is 250, because the depth of this ground beam is 300. We deduct this 50. The distance from the top of the ground beam to the ground is 50. So we shall take 1850, we deduct 250. Alright? Then we shall add the depth of the ground beam. Alright? So after we have deducted 250 to the bottom of the ground beam, we shall add 300, so that we can get up to here, up to the top of the ground beam. Or else we can take 1850 plus 50, because we want the depth from here up to here. Alright, then we need to deduct this cover at the below here. You see, these reinforcements are coming into the footings, and they do not get to the bottom of the footings. We have to have a concrete cover. So we shall take 1850 plus 50, 1900. We deduct this cover, which is 30 millimeters. Alright, then we need to deduct also 2y16. Why 2y16? Here below the footings we have reinforcements going this way and reinforcements coming this way. Remember, this is the footing of the column. We have reinforcements coming this way and reinforcements coming this way. Then we have the reinforcements attached to it. So for this reinforcement, it lies on 2 reinforcements, one coming this way and another one below that one going this way. Then we need the concrete cover. So we need to deduct the concrete cover first of 30 millimeters. Then we need to deduct the thickness of two reinforcement bars, one below, then the other one on top. Then this bar is on top of those ones. So the thickness of one bar, alright, the thickness of one bar of Y16 is 0.016 millimeters. If there are 2, it shall be 0.16 millimeters times 2, because there are 2 Y16s. Then we need to add the length of the bend. You see these bars, they have some bend. What is the formula for finding the length of that bend? It is 5.5 D. Alright, so 5.5 D, it shall be, if the diameter of these ones coming this way is Y16, it shall be 5.5 times 0.16. Alright, So we need also to add some length from above the ground beam for the overlaps, so that it can be able to lap with the reinforcements coming from up there. All right, what is the length that we allow for overlap? It is 40D. So if the reinforcement bar is Y16, it shall be 40 times 0.016. all right, so you can be able to see that full calculation here, whereby we say the length of the bar shall be, the total depth is 1.85. You deduct for the ground beam to get to the bottom of the ground beam, then you add for the ground beam so that you can get to the very top of the ground beam, then we deduct the cover at the bottom, then we deduct the thickness of two Y16s below that reinforcement bar. Then we shall add the bends, two beds, then we shall add the length for the overlap. So the total length of one bar in a stump of 250 by 250 shall be 2.57. So we have two stumps. In this stump, we have two stumps measuring 250 by 250. We have four sides. We have four reinforcements. Why do we say four? Because if you can see, we have this column. We have four reinforcements at the corners. All right. So we have two stumps, four reinforcements in each stump. Then the length of one reinforcement is 2.57. So the total length of one bar of all the bars is 20.56. Y8, Y16 diameter steel bars. All right. Now that one is the length of the bars for the stump measuring 250 by 250. Now those are the bars that are standing. We need to calculate the length of the stirrups. These ones that are going around the rings, all right? So they are called the stirrups. And also they are called the links, all right? So we need to calculate the length of the links. The links, if I'm to sketch, they are rectangular, they are curved rectangular. Then they have some hooks, all right? If they are like that, we want to find the total length of this stirrup. It shall be 250 by 250 by 250 by 250. All right. Then this side it has a cover of 25. This side a cover of 25. This side a cover of 25, and this side a cover of 25. So on the length side, if it was 250 for the column, we shall deduct two covers, this side and this side. For the wing, we shall deduct this side times this side. And because it's a square, we shall take one side 0.250, we deduct 0.050. All right, two sides shall be 0.05. all right, so it shall be 250 deduct 25, that makes 50, so it gives you 200. So if the length of this stirrup here is 200, removing the cover all around, it shall be 0.8. okay, then we shall add this length of the hooks. One hook we shall use 24D. So if it's a diameter of D6 for the stirrup, we shall use 24 times 0.006. all right, so the total length of the stirrup shall be 0.944. So the length of this stirrup, the total length of the bar that we shall require to do the stirrup is 0.944. That one is for coming up with one stirrup. How many stirrups do we need? All right, that is what we shall calculate here. The stirrups shall be distributed from the below the ground beam to below here, inside the concrete footing. So the stirrups shall begin above the concrete cover and above the two reinforcements for the footing. Then it shall be just below the ground beam. So what is this depth from here up to here? So we shall take the total depth here, which is 1850. Then we shall deduct the ground beam. Then we shall deduct the cover and the two reinforcement bars below here. And it shall give us a total depth of 1.538. Alright? So we are told the spacing of the stirrups is 200. So it shall be 1.538 divided by 200 plus 1, and it shall be 8.69. So say 9 stirrups. So we have 2 stamps, 9 stirrups in each stamp, and the length of the bar coming up with 1 stirrup is 0.94. So the total length of the bars we shall buy to do the stirrups shall be 17 meters. All right, so that we are already done with the length of the bars for the stamps in the 250 by 250 column. We have calculated the total length of the stirrups. Now we shall go to the stamp measuring 200 together with the length of the stirrups. Remember, we are done with this stamp measuring 250 by 250, but this one measures 200 by 200 because the size of the footing is small. So this one is the one that we are taking off now. So the length of the bars coming down the stamp, we shall calculate it just like the other one in terms of height. So the height shall be 1850. Then we shall deduct 250 up to the below the ground beam. Then we add 300 to get here up, or we take 1850 plus 50 so that we can know the length from here up to here. So it shall be 1900. Then we shall deduct the cover of concrete below here, which is dirty. We deduct the thickness of 2 reinforcement bars of Y16. Then we shall add the length of the bends here, and each bend is 5.5D. Alright, so 5.5 times the diameter, because the reinforcements coming down the stamp, they are Y12 bars. So it shall be 5.5 times 0.012. So then we should give an allowance for overlaps with the column bars coming from the top. So the lapse is 40D. So 40 times the diameter of those bars, which is 12. So it's 40 times 0.012. Alright, so the total length of the bars coming up shall be 2.384. If you follow up this calculation, you'll be able to understand the total length of that bar, where it's coming from. So how many reinforcement bars do we have in each stamp? We have 4 reinforcement bars in 4 stamps. Each reinforcement bar is measuring 2.38. So the total length of the bars is 38.14. Then we need to calculate the length of the stirrup. The stirrup, remember, in this case, the stamp measures 200 by 200. So if it is 200, it's a square measuring 200 by 200, and we have to do a cover of 25 this side, 25 this side. So it shall be 200 deduct 25. So 200 deduct 50, you get 150. Then we have how many sides of that of the stirrup? We have 1, 2, 3, 4. So we multiply by 4. So we shall get 0.60. Then we add the size of the hook, and the hook is usually 24D. So 24 times the diameter. The stirrup is M6, so it is 24 times 0.006. So we shall get 0.144. So the total length of one stirrup shall be 0.74. How many stirrups? The total number of stirrups is determined by the height on which the stirrups are distributed. The stirrups are distributed from below the beam to above the concrete cover and above the 2 reinforcements in the footing. So the total length from here up to here, it is 1.538. So we divide by the spacing of the stirrups. You see the spacing of the stirrups is written here. The spacing of these stirrups is 250. For this one was 200. So this one you divide by 250 plus 1. So how many links do we have? It is 7.52. So say 8. So when you are coming to book them, we shall say we have 4 stamps. Alright, so we multiply by 8 sides. No, we have 4 stamps. Then we multiply by 8 number stirrups. Each stirrup is 0.74. So we shall get the total length is 23.81 mr of M6 diameter link. We shall now look at how to book these takeoffs, the ones we have done, these bookings, in a bill of quantities. So we shall begin with the first one, which we used here. The first takeoff we did, it was about excavation. How do you book these things in a bill of quantities? So we have the excavation work. We started with excavation of topsoil with 150 millimeters thick, and we got 2.55. So when you come to the bill of quantity, you see the bill of quantity is usually like this. There's the item number, there's the description, the quantity, the unit, the rate, and the amount. Remember, we usually just come add the rate, then we multiply by the quantity, by the rate, we get the amount. Quantity times rate, we get the amount. So if we want to get the total cost of coming up with the total cost for the excavation, concrete work, formwork, and reinforcement in these columns, column footings and stamps, we shall just add the total cost here. So when we are coming to book it, we shall write excavation work. The first item, excavation of topsoil, 150 millimeters. And we write the total that we got, 2.55, and it's in cubic meters. Just as you can see, we got 22.55 meter cubic. All right. We shall come to excavation of trench depth not exceeding 1.5. We got 25.50. So we shall come and write excavation of trench depth not exceeding 1.5 meters. The total volume is 25.50. It is in cubic meters. We go to the third item, which is excavation of trench depth not exceeding 3 meters. So it shall be excavation of trench depth not exceeding, it's exceeding 1.5 but not exceeding 3 meters, and the volume of the soil is 4.25. It is in cubic meters. We go to concrete work. We book the first item, concrete grade 1:3:6, 20 millimeters aggregate for footings. Where do we get the concrete? We shall get it in the takeoff that we did. We got 6.80. So we shall just come and add 6.80. All right. So we shall go to the second item, concrete grade 1.24, 1:2:4, 20 millimeters aggregate for stamp. We get 0.34 cubic meters. So we shall come and refer. It's this one. We got 0.34. All right. We come to the next one, formwork. Rough surface formwork for footings. We got 16 meter cubic, 15 meter squared. So we just write here, the item is formwork. Rough surface formwork for footings, we get 16 square meter. The next one, rough surface formwork for side of stamp, we get 6.24. Can we confirm whether we got that? It is here, rough surface formwork for side of stamp, 6.24 meters. So we go to the next item, which is reinforcement. When we are entering the reinforcements, we will begin with the Y16, then we go to Y12, then we go to R6. When we come to Y16, we will take all the values that we have got for Y16. Then we will add them and get the total. For example, the one that we did, the reinforcement for the stamp, we got the reinforcement for the stamp. We start with reinforcement for the footing, 2000 by 2000 by 400. The total length was 59.36. This is Y16. The next Y16 was the reinforcement for footing, base 1500 by 1500 by 400. We got a total length of 64.80. Then we got reinforcement for stamp 250 by 250. Y16 we got 20.56. So we shall take the total of the three. The 59.36 plus 64.80 plus 20.56. We got 144.72 meters. When we are buying a reinforcement, we buy them in kilograms. How do we find the kilograms of 144.72 meters? We usually take R pi R squared. You see, a reinforcement bar is usually like this. It's like a cylinder. So we take pi R squared cross-sectional area times the length. So pi, that 3.14 times R, this one, Y16, it was 16 millimeters diameter. So the radius shall be 8. 8 millimeters diameter in meters, it shall be 0.008 squared times the length, total length of the reinforcement. Then we multiply by the density of the steel bar to get weight, because mass is equals to density times volume. So we get to 28.30 kilograms. For the Y12, we shall get the total meters, and Y12 was only used. in the reinforcement for the stamp 200 by 200, and the Y12, the meters was 38.14. So we shall write 38.14. Then we calculate the total volume by taking pi R squared. Y12, radius of 12 is 6 times the length. We multiply by the density. We get the mass. We go to R6. R6, we used to R6 in the stirrups, and the stirrups we got. The first one was 23.81. 23.81 M6. Then there's another M6 that we got. It was the stirrups for the stamp, the links for the stamp 250 by 250. So this one was for the stamp 250 by 250. The other one was for the links or the stirrups for stamp 200 by 200. So we get the total of this one and the other one. So the total for M6 shall be 17 plus 23.81. We get 40.81 meters. So to get the volume of those reinforcement bars, pi R squared times the length. R, the diameter is 6. The radius is 3. So then we multiply by the density to get the mass. So the mass of the R6 shall be 9.05 kg. So when we want to get the total cost of doing all these things, we'll just put the rates in the columns. Then we just multiply quantity times rate, we get the cost. Quantity times rate, we get the cost. Then when we add all these costs, we shall get the total cost for doing the excavation work, concrete work, formwork, and reinforcement. Alright, so we are done with the takeoff for the reinforcement, excavation, and formwork for the foundation concrete columns, in the stamps, in the footings, and in the footings.